What do these maps mean? And how will I find what I'm looking for? I know. I'll bake a cake. I'm going to make a rainbow cake in order to show the layers of topography. Start by adding dry ingredients together and mixing them, then wet ingredients. I allot the wet ingredients into 6 different portions and color each. I put the colors in rainbow order, but the last color is a purple made from mixing red and blue and is not actually violet, nor are there 7 colors as Newton named them. Set it aside and get another one. We'll make scrambled eggs later. Here I'm mixing so that I'm turning this mixture from a heterogeneous mixture to a more homogeneous one, or at least I'm trying. I used the scale to find the weight of these ingredients so that I could add them equally to each portion. Now here is where I began to really have some difficulties, and I think that I could come up with a much better way to make a rainbow cake, perhaps doing things in a different order. What would you do? Maybe you can leave a comment below so that others don't have to suffer from the same difficulty I have had. Notice that as I beat the eggs, they decrease in density quite a bit, not because they lose mass, but because they gain volume. I used the scale once again to portion out the egg whites equally, and then put things in the oven to increase the speed of chemical reaction so that the cakes would gain volume, once again decreasing their density. A quick review of superposition. The bottom layer goes on first, and higher layers are more recent. Now that all of the layers are in place, I'm starting to cut into the cake to show the topography. One of the interesting things about our local geology is that it is dominated by glaciation. Glaciers tend to form great U-shaped valleys, and here I've cut one out of the central portion of the cake. Water tends to make V-shaped valleys as it erodes, and it tends to flow down in the middle of those U-shaped valleys, and so I cut a V-shape down that central U-shaped valley. Sometimes glaciers are high up and get interrupted by another glacial valley and make a hanging valley, which I've tried to show at the side. They also make interesting structures called cirques, which I've just made on the side of the cake. I'm sure you will recognize that the word cirque sounds similar to the word circle, and you can see that it indeed is a circular shape. The knife I'm using to create all this topography was given to me by my cousin and is my favorite knife. He named it Brandring, the Rye Hammer, after Gandalf's famous sword, although this sword is more used to cleaving bread and not enemies. Notice once again the terrific decrease in density as I make this kind of frosting. The 7-minute frosting makes the cake look a little bit like our Chugach Mountains do in the wintertime. Before I frosted the cake, I took a picture of it. In this picture you can see all of the different colored layers. These layers correspond to the relative elevation of the cake. The red is at the top, then orange, and then yellow below that green, then blue, which is kind of a bluish green, and finally the purple color. I projected this picture on a computer screen, and traced all of the regions of color so that I could form an elevation map that I can use to understand topographic maps in general. Notice that the lines either form loops or end at the edge of the cake. They never stop in the middle of the image. I marked all the red regions with an R. This helps me keep my orientation, as the elevation markers would in a real map. Then I made transect lines. These are lines that go across the map. Remember, trans means across, as in Transylvania, across the woods. I graphed the elevation profile of each transect, starting with the 16th one, but I soon realized that I should start with the first one, as it would be easier to make my three-dimensional map if I started at the top instead of the bottom. As I make these transects, I'm not using information directly from the cake. I'm only using my map. And also notice that the elevations are not perfect. They're approximations. The same is true on a topographical map. You can only see where elevation lines are, so you only know the elevation when you are actually on a line. In all of the other places, you need to interpolate or guess between the points. You can see I've made a key of the color layers that I put to the side of the map, so it's easier for me to tell how high I should draw the graph from each point. I'm graphing the point where it crosses the transect line. Now that I've glued them all together, I can see the three-dimensional shape that's shown by the map. Let's compare it to the actual cake. Here they are, three versions of the same map, or cake. And you can see the high parts that correspond to each other. This valley, steep valley, this deep valley here, here, and here, these high points, this kind of flat area, that's a high also, high points, and the flat area that's high. Here's this guy on skis, really laden with a lot of equipment. I hope he knows how to use a map. I sure do like the look of these snowy mountains. And I thought it looked delicious on the outside. Now I know. It's right here.